Our team analyzes the causes of hacking accidents in corporate or private systems and collects and analyzes information if there are malware to prevent secondary damage. Recently, with the advent of machine learning, our team is also conducting research on how to analyze malware using machine learning. Let's take a look at the table of contents. First, let's find out what machine learning is. Second, this is the method of applying machine learning to malware number 1, random forest. Random forest is one of the machine learning algorithms. Third, there is one of the deep learning algorithms called CNN. Lastly, I'll briefly explain how we are using this machine learning to apply it to our business. First, what is machine learning? You can think of machine learning as one of the AI categories. Then, what is AI? To explain briefly, AI is just a computer that thinks and judges. And there is a part called machine learning in it. And the machine learning part is divided into 3 categories: supervised learning, unsupervised learning, deep learning. Supervised learning is a method of machine learning to infer a function from training data. Training data generally include attributes for input objects in the form of a vector, and show what the desired results are for each vector. Among these deduced functions, the output of successive values is called regression, and the indication of what type of value a given input vector is called classification. The task of the supervised learner is to correctly guess the values that you want to predict for a given data from the training data. To achieve this goal, the learner must be able to generalize and handle situations that have not emerged from existing training data through appropriate methods. Unsupervised learning is a kind of machine learning and falls into the category of problems that determine how data is organized. Unlike supervised learning or reinforcement learning, no target is given for input values. Deep learning is defined as a set of machine learning algorithms that attempt high levels of abstraction through a combination of several nonlinear conversion techniques, and can be said to be a part of machine learning that teaches a person's way of thinking to a computer in a large framework. Machine learning was mentioned in the summer of 1956, which was earlier than expected. 10 scientists at Dartmouth College said machine learning came out when they mentioned artificial intelligence. From 1956 to 1974, it was called the Golden Age, and based on theory, it developed relatively successful programs such as natural language processing. From 1974, software continued to develop, but hardware was not able to keep up with it. So it faced limitations in computer performance and was cut off government support. Then since 1993, hardware was developed rapidly, marking the second golden age. I think that the keyword machine learning was mentioned a lot in Korea when Isedore and AlphaGo played Go in 1916. Then in October 2017, AlphaGo Zero appeared, fighting AlphaGo 100 times and winning 100 times. We can say that machine learning and AI technology are developing at a rapid pace in just 1 year. Machine learning is still being used in various fields, and I have brought a simple example of it. There are pictures of dogs and cats on the screen, so you can think of them as machine learning models. The picture of the dog and cat is learned through machine learning algorithms. The computer goes through so much data that it can identify dogs and cats that it learns and serves dogs and cats. You can think of it as a Google Photos, and if you put a picture of a cat in Google Photos, you can identify the cat and even check the breed. The most basic example of machine learning is to identify whether it is a cat or a dog when a picture of a cat or a dog is put into the model. If you give it a picture like this, it can judge a dog and a cat. So analysts think, these days a lot of malware is being printed and analysts can't do it all. So I hope that there will be a model that can tell if a confirmed malware is spyware or ransomware by learning it like a dog or a cat. So many analysts are studying how to classify malware using machine learning. Research is expected to be divided into 2 main areas. First, I have brought some papers in the field of detecting malware by studying machine learning. They include automatic analysis of malware behavior using machine learning, analysis of machine learning techniques used for behavior-based malware detection, and applying machine learning algorithm to method for detecting malware using opcode. I have brought papers and materials classifying malware using machine learning. In the Microsoft Malware Classification Challenge, challengers analyze samples of malware code using disclosed Microsoft Vaccine Server data on Kaggle website. And challengers need to classify the given malware into 9 families. Family on here refers to a category that contains a specific target like a cat family and dog family in biology. In addition, there are 2 published papers recently. The 2 papers introduce LSTM and GRU language models, and malicious code classification using character-level CNN, and malicious code classification using spider neural networks. In addition, there are many other materials that detect or classify malware through machine learning. So far, I've explained about machine learning. Next, let's find out how to apply malware to machine learning. I said the first method was random forest, but before I explain it, I think the concept of machine learning may be unfamiliar, so I brought the machine learning process first. The first step is to collect large amounts of data. The second step is to characterize a large amount of data collected. There is also a way to let a computer learn recklessly, but in most cases, algorithms extract the characteristics of the data and teach them. The third step is to select the framework. The framework supports the use of so many algorithms. The fourth step is algorithm selection and learning. If you have selected the framework, it will select the data and the appropriate algorithms among the algorithms it contains. The final step is evaluation. Once the learning is finished after selecting the algorithm, it evaluates whether the learning has been done properly. If the learning accuracy is low, check the algorithm first and correct the problem in reverse order. To apply this to malware, data collection will require a large collection of normal, ransomware, and other malware. Extracting characteristics require extracting characteristics of malware, which extracts characteristics such as meta information, behavioral information, and static information. Once the feature has been extracted, you determine which framework to study malware data. After selecting the framework, select and learn algorithms. The last is to evaluate the results of the study. There is also a variety of evaluation methods. You can choose a good or appropriate evaluation method and evaluate it. One of the methods of extracting the characteristic of step 2 is to extract the characteristic of the malware in the DOS header, PE header, and optional head among PE formats. And among them, anti-headers, for example, there are machines, major OS versions, export tables, and import table. There are some of these that are characterized by and without malware, but I'm just trying to extract them all and try to teach them. You don't know what's good feature when you look at it. Unless you're really an expert, you don't know what information is good until you learn it. So let's pick one and let them learn. There are ways to extract these features and put them in the database, but we are in the position of studying, so we can make a CSV file and keep it. Now we need to put the CSV into the framework, but before we do, we have a lot of frameworks, so I'm going to briefly explain how to choose the framework. As you can see in the graph, most users use scikit-learn or TensorFlow as a machine learning framework. Let me explain them briefly. Scikit-learn is a library in Python that provides many unsupervised and supervised learning algorithms. It's built upon some of the technology you might already be familiar with, like NumPy, Pandas, and Matplotlib. TensorFlow is an open-source library for numerical computation and large-scale machine learning. TensorFlow bundles together a slew of machine learning and deep learning models and algorithms and makes them useful by way of a common metaphor. It uses Python to provide a convenient front-end API for building applications with the framework, while executing those applications in high-performance C++. We'll give these two options and compare them. Scikit-learn is easy to handle and is specialized in learning simple machine learning algorithms as high level as C language. TensorFlow is a low level, so it can be relatively difficult to learn machine learning algorithms. And think of CNN as a specialized framework for deep algorithms. I usually do my work with Scikit-learn when I study or work. However, there is a lot of data and TensorFlow is used when working at the system level. This is how to choose the algorithm. If you have to choose an algorithm, just follow it. Then you can see which algorithm to use. Let's start from the start. Determine whether there are more than 50 data to be learned or less. If there are less than 50 data, it is judged that the number of data is insufficient and sufficient data should be brought in. If the amount of data is greater than 50, it should be determined whether it can be categorized. If categorization is possible, you can use the algorithm in clustering and classification. If it is not possible to categorize, use the algorithm within the regression or dimensionality reduction. I choose the random forest algorithm that I was supposed to introduce in this chapter. Before we talk about random forest, let's talk about the decision tree. What's the decision tree? Perhaps you know about the binary tree. It's like that. Decision trees are a non-parametric supervised learning method used for classification and regression. The goal is to create a model that predicts the value of target variable by learning simple decision rules inferred from the data features. It is a form that is continuously divided into two parts. I drew a simple example myself. If the debug size is greater than 1000 on this malware, when the sample is inserted, go left. If the RSC size is less than 2000, it is considered normal. But if the export RVA is greater than 3000, it is normal, but if it is less than 3000, it is malware. It is the decision tree to judge in this way. Random forest is an upgrade to the decision tree. Random forest is a machine learning or a kind of ensemble learning method used in classification, regression, etc. and operate by classifying or outputting average forecast from a number of decision trees formed during training. From tree number 1 to tree number 4, each is the decision tree we just described. The collection of several decision trees is called random forest. Each decision tree judges that tree number 1 is normal, tree number 2 is malware, tree number 3 is ransom, and tree number 4 is malware. The random forest algorithm votes or evaluates this result comprehensively. The data showed that it was malware. In a word, you can think of it as a random forest, where you can gather together several decision trees and make a comprehensive judgment. We've checked the algorithm sample before and selected the framework and algorithm, so it's time to learn. I brought the data to teach. We have trained data and test data, but you don't have to know this yet. Then we collect the malware and put it into an algorithm called random forest. Now that we're past the verification phase, where we put in data to validate that this is a good learning experience, we're done with a series of steps. Now let me explain about CNN. I don't know much about the exact mathematical algorithm of deep learning. I can't tell you the exact algorithm, but I will explain how to use it. First of all, in the case of CNN algorithm, the KISA is continuing research with many universities. There are research for malware mutant group identification based on data mining and a study on the conformity of malware analysis algorithm based on machine learning. This is the CNN algorithm. CNN algorithm is basically the appropriate algorithm to judge a picture. I've explained earlier about dogs and cats compared to machine learning. But in fact, we're using a lot of CNN algorithm. I think if CNN, the appropriate algorithm for this picture, learns malware by imaging it, we can sort out the differences between images like dogs and cats. If you express malware in binary, it appears as 010101. If you put it together, you will get the hexa value. It's pre-processed and imaged. The algorithm in the middle of the imaging process continues to disassemble the single image so that it can produce the right results. But you don't have to worry about this. Anyway, you can think of CNN as an algorithm for learning and classifying images. I also brought PE format and explained it when extracting the features of random forest. In the case of CNN, Python has a code to image the value of hexa, so I recommend you to make it yourself or bring the appropriate code from the GitHub and use it. If you use code to image hexa values, it comes out like this. What is the CNN algorithm? CNN is the most commonly used algorithm for deep learning, where model classify images, videos, text, or sounds. CNN is especially useful for finding patterns that recognize objects, faces, and scenes in an image. CNN learns directly from the data and classifies images through patterns without the need to manually extract features. CNN is used a lot in areas where object recognition and computer vision are needed, such as autonomous vehicles and face recognition applications. Depending on the situation, CNN can be created from the beginning, or pre-validated models can be used with data sets. There are 3 reasons why CNN is useful. First, you do not need to manually extract features because you learn them yourself. Second, it has the highest level of recognition results. Third, it is possible to relearn and utilize CNN for new recognition work based on existing networks. When you put malware in the CNN algorithm, these results came out. Confusion matrix refers to a table often used to describe the performance of a classification model in a test data set that knows the true value. The actual label is on the left and the predicted label is below. First, if you show 620 drop on the classification model, 525 is correctly set as drop, but 10 is ransom, 55 is remote, and 30 is download. Second, if you show the classification model 585 random, 565 is correct, 17 is drop, 3 is remote. Third, when I show the classification model 548 remote, 447 is correct, 71 is drop, 9 is ransom, 21 is download. 4. When I show the classification model 321 downloads, 225 is correct, 50 is drop, 16 is ransom, 30 is remote. Now, let me briefly explain how we apply this to our company. Our company is extracting the following features for machine learning. Our company does not only do malware, but also collects host information, as well as malware, because we have to investigate and learn PCs and servers that have been damaged by invasion. IP and URL, host name, user agent, sender email, hosting, and so on. First, let me tell you more about how to extract from malware. Think of it as a malware. This is called a sandbox container, and you can think of it as a tool or software for regression analysis so that malware do not spread in one space. It extracts the regression information from the sandbox through the metadata extraction agent in the malware. Second, the binary characteristic information extract module uses IDA and SSDeep among malware analysis tools to extract binary work. The right screen is the IDA screen. In addition to malware, they send the document through spear phishing among malware document or doc document with malware bound. It's not even a special X, but when we ran it, it suddenly downloaded docx from the document to PC. To detect this, we are also extracting characteristic information of malware documents. And finally, we do host information. We have a stake of DBs, and if we want to use them in machine learning, we have to go through a regularization agent. Since we can't make the image with CSV, we need to make it regularized. In the regularization process, filtering, cleansing, and conversion are included in the DB. Think of DB as feature DB. It contains things like well-processed n-gram, API sequences, and images. Now it's going through the pre-processing phase. Each algorithm has a different way of putting data, so we go through the pre-processing stage once again. And you're going to choose the appropriate framework or algorithm, and then you're going to go through the analysis. This screen is a machine learning platform developed by our company. If you insert a malware, you can think of it as a platform that shows what kind of malware it is. We've been building it for about 2 years, and we are upgrading it through business. You can think of upgrading as not changing the UI, but continuing to study how to add algorithms and improve accuracy. I'll finish my presentation. Thank you.